Welcome back, students. Mr. McCoy here. Today we're going to cover two different concepts. The first one is a small one called variable scope, and it's one set of the notes for this unit. And the other one is the main attraction, while loops. First, let's get through this variable scope business. Scope is a vocabulary word that likely will show up on tests. It refers to where you can use a particular variable. You might think of it as the visibility of your variable or the lifespan of your variable, but whenever you declare a variable and give it a name, that variable can only be seen by your program in certain parts of your program, and that's what we mean by scope. So the technical definition is that a variable scope is everywhere inside the innermost curly brackets where it's been declared. And that can get kind of hard to follow with all the different curly brackets you're going to have all over your program, so I think I have a good way of showing you exactly how that works. So if you look at this example, I've shown you the scope of our two variables. We've got a variable A and we've got a variable B, and the boxes are highlighting the scope of those particular variables. So the variable A is declared near the beginning of my program, and you can't actually see the main method. It has a curly brace up here, and there would be a closed curly brace down here for the main method. And you can see A anywhere within that method. However, the variable B was declared inside of an if statement. So the variable B was declared inside of these two curly braces, and therefore its lifespan, or its scope, the area in which we can see the variable B, is only contained within these brackets. So as soon as we declare it, it becomes an active variable, and as soon as we get to this curly bracket down here, then the variable B dies and is no longer visible. So whenever we get down here and try to print B, we're going to have a problem because B isn't visible at this point, and you'll get an error. Here's another similar example. Because A is declared up here, you can't see the open brace for the method or the closed brace for the main method, but they're there, and that would indicate the scope of the variable A. But variable B, it's very easy to see the scope because B is defined inside of these curly brackets. There's an open and there's a close, and on the inside of those is where we declare B. So B becomes active at this point, and as soon as we get to that curly brace down here, B dies, its lifespan ends, it's no longer visible by your program, whatever you want to call it. The point is B no longer exists whenever we get down to this line. So it's fine to go inside of more brackets. So we declared B right here, and then we moved inside of brackets. We can use B on the inside of these brackets, and this curly bracket does not kill B because B wasn't declared on the inside. B was declared on the outside of these brackets. So B is still fine to get down here, but then whenever we get down to this line, we're trying to access B outside of the curly brackets from which it was defined, or declared rather. I should say declared, not defined. This example shows how once a variable dies, it's then available, that name is available to be used again. So we have, again, the scope of A shows that it's throughout the entire program. However, inside of this if statement, we declare a new variable B, we print it, and then that if statement is done. We have the closing curly brace, and our B variable dies. Then we have another if statement, and on the inside of this one, we can declare a brand new variable B to be used again. Usually you would get an error if you tried to declare B after you already declared B, but keep in mind this B up here died at this closing brace. Anywhere beyond that, we're free to declare a new variable B if we wanted to. The reason this is okay in Java is that these two variable B's do not exist at the same time. Remember, our program runs from top down, so it does this, then it does this, then it goes here and here. So at this point B exists, but then whenever we move down here B no longer exists, and so we're free to create it again. We would not be able to create a new variable B inside of the scope of the previous variable b. So this would be bad. Alright, here's a warning that what you're about to see might not make any sense because we haven't covered loops yet, but there is some scope information you need to know about loops, and you might want to revisit this part of the video after you've learned some stuff about loops. Check back on these notes later on, they'll make more sense to you. But we're about to learn all about loops, so there's some notes in here that shows you the scope of variables that are defined inside of loops versus variables that are defined outside of loops. So you might want to look back to this later on. But let's move on to our main attraction, learning about while loops. Okay, so while loops are the first type of loop that we're going to learn about. We'll also learn about do while loops later on today, and then in a future lesson you'll learn about for loops. So what is a loop at all? Well, maybe you wrote some code and you want that particular code to be run several times with your program. You know how right now whenever you run your program it does some stuff, and then if you want to do that stuff again you have to rerun your program. Well, maybe you want to tell your program to do that stuff several times before it's done. Rather than copy pasting the code in there several times, you could set yourself up a very nice while loop. It's very similar to an if statement in that you have to set up a test condition, and if a test condition is true then it runs the code inside of the loop. It's different than an if statement though, because whenever it finishes running the code inside of it, it goes back up to the top to see if the test condition is still true, and it could keep running it over and over again. If the condition is still true, the code block runs again. Now that's a whole lot of words in those couple of slides, and maybe you're not really a word person, maybe you'd like to see some pictures. Let's do that. So just like an if statement where we said if and then we put in a test condition, whiles look the same. We put while and then we put a test condition, like a is less than 5 or something like that, something that evaluates to true or false. This needs to be a Boolean expression. So if this evaluates as true, we have a true test condition, then we're going to run all the code between the braces, just like an if statement. The difference is that when we get down here, rather than moving on to the code below, we're going to jump back up here and see if that test condition is still true. If it's still true, we're going to run all of that code again and then jump back up. And we keep doing this basically forever until the test condition becomes false. So as you can see, there's going to be a need perhaps somewhere in this code for something to change that causes our test condition to become false. Otherwise we would be stuck in what's known as an infinite loop. It'll just keep going forever and ever. Let's look at a real example. So in this one we have a variable called I, and we give it an initial value of 0. Then we set up a while loop. We say while I is less than 5. So it treats it just like an if statement. Is I less than 5? Well, yeah, it is. I is 0, and that's less than 5, so this is true. So let's run the code inside of the while loop. It says to print I, print a space. Then we're saying I needs to change. I goes up by 1. So I now has a value of 2. It reaches the end of this. It jumps back up to the top. The while loop tests its condition again. Is I still less than 5? Well, I is now 1. So yes, it is less than 5. And it keeps going over and over again until finally this becomes false and your output ends up looking like that. Now with loops things can start getting very confusing because you're used to just looking at your code and assuming everything is going to happen once, or in the condition of if statements maybe some lines won't even run at all. But in a while loop now you have to worry about how many times that section of code is going to run, and you want it to run the correct number of times. So it's going to become important that you understand how to trace through while loops. And so that might require that you start writing some stuff down while you're planning things out, or while you're trying to debug what's going wrong with your code. And let me show you how you can do that. I'm going to try some new technology now. I'm going to try drawing on this slide. Okay, so in this example it says that we have an integer a and it's set to a value of 1. So I'm going to keep track of the values stored in a right over here. So let's say a, and it has a current value of 1. Now let's check our test condition for this while. While a is less than 3. Is a less than 3 right now? Well, it's 1. 1 is less than 3, so that's yes. So that's true, and we need to now run the code inside of the block. System.out.println A. So what's our output? It's going to print line A, and A is 1, so our output, we're going to have a 1 print, and then it's going to go down to the next line, and it's waiting right here for us to print some more stuff. Then it says A++. That means we're going to increment our value of A. So A is no longer 1, A is now 2, and we've reached the end of our while loop, so we're now going to go up. Back to our test condition. That's a bad arrow. Can I get it? That looks a little better. Okay, so our while condition, we need to test this test condition again. Is A less than 3? Well, now A is 2, and that is less than 3. So yes, we are going to run this a second time. System.out.println A. Our current value of A is 2, so that's going to print. We're sitting down here waiting to be printed, so 2. And it's a print line, so it goes down to the next line, and our cursor is sitting right here waiting for us to print something else. A++, so we're going to increment the value of A again. It's no longer 2. Change that to a 3. And we've reached the end of our while loop. We follow this arrow back up here. While A is less than 3. Let's see if this is still true. Is A less than 3? Well, A is 3. 3 is not less than 3. So this will not run a third time, which means that we are done. We're not going to do this again, and now execution of our code moves down here, and if there was more stuff down here, that's what we would do next, but there's not anything yet. So that's the output of our code. It's going to print a 1, it's going to print a 2, and that's it. So it might be a good idea whenever you're trying to figure out how to structure your while loop that you start keeping track of what your variables are, writing them out, tracing through your program, because it can get really complicated later on. There's another keyword in Java called break. Break is handy in that it allows us a way of getting out of a loop anytime that we want. Usually a loop is going to keep running over and over again until the test condition is false. But you could put a break statement anywhere inside of that while loop, and if that break statement is run, it'll immediately break out of the while loop and go down to what's after your while loop. So let's see what's going on in this one. I'm going to trace through this one just like I did before. I've got a variable I, and it's set to 0, so I is 0 right now. Is I less than 5? Yes, it is. So we're going to run the inside of this while loop. If I equals 1, is that true? No, that's not true. So we're not going to run this inside of the if statement. And then it says I++, which means our I now changes from 0 to a 1. And we've reached the end of our while loop. And of course we need to jump back up to see if we need to run our while loop again. And it says I is less than 5. Is that true? Yes, I is 1 right now, which is less than 5, so our while loop is going to run again. If I is equal to 1, is that true? Yes, it is. So this time that if statement is true, which means that we go inside and we have this break command. Break means we're going to leave our while loop. This right here represents the end of our while loop, so a break statement means immediately jump down here and start running code below that brace. So we never actually ran this again, and we didn't run this loop. You might at first glance think that this loop is going to run 5 times because we're starting at 0, we keep going up by 1, and we're going to keep running until I is equal to 5, basically. But there is another piece of code in here that tells us to leave the loop early. On this next slide, it's the exact same code we just looked at, except after the loop it has a print statement showing that the current value of I is 1, which is what we determined back here. Whenever we left the loop, I is 1. So that's why it prints 1 there. Alright, another kind of loop. This loop is just like a while loop, except the order of condition testing is a little different. This one's called the do while loop. Let me look back up at a while loop just for a second. With this while loop, we're going to evaluate if this is true, and if it is true, then we run the stuff in here. Well, what if this was never true? Let's say I is 9. If I is 9, then while I is less than 5. Well, that's not true, so we immediately skip that while loop and just go straight down here to the print line statement. And this stuff inside the loop never ran. So it's possible with a while loop that the inside will never run. However, with a do while loop, the inside of the loop is guaranteed to run at least once. The reason is the condition isn't tested until after the loop is done. So here we start off with a do, we jump inside, we do the stuff inside, and then we get down to the condition testing. So let's trace through this one. Our first thing is we have a variable called isDone. isDone, sorry for my handwriting. isDone is true. So we're going to do something, okay? So there's no test condition here. We just immediately jump on the inside. Do this, so we print the word hello. Then we go down, we're at the end of our loop, and now we have our test condition at the bottom. isDone equals false. Is that true or false? Well, isDone is true, so we have true equals false. So this entire thing evaluates as false, and therefore we do not jump back up here. We would jump up there. If this was true, we would jump up here, but this is false, so we're not going to jump up there. Instead, we just continue execution down here. And so our loop never actually loops, but it does run one time at minimum. So why do we even have do while loops? It seems kind of strange. Well, I mean, it's very useful if you think about it. What about the labs that you've been writing? We know we want to run the program at least once, otherwise we wouldn't have hit the run button. So you could have a program that you hit the run button, it performs an action, and then it asks you at the end, do you want to do that action again? And if you say yes, then it loops back up to the top and it does the action again. And then you ask, do you want to do it again? You say no, and then it's done. But you know you want to run it at least once, so it would be silly to start up a program and then immediately say, do you want to run the program? Well, of course you do. You wouldn't have run the program otherwise. And lastly, we have a continue statement. So that's another keyword similar to break in that it's useful only within looping context. And what continue means is let's go up back to the test condition and skip all remaining code in our loop. So it doesn't leave the loop, but it does say we're done with this current run of the loop and let's move on to the next one. Now that's really hard to understand, so let me trace through it for you. We start off declaring I as 4, and then we say while I is less than 10, we're going to run this code. Well, is I less than 10? Yes. So let's run this code, I++, so I is going to increase to 5. If I is equal to 7, well, it's not equal to 7. That's false, so we won't run this statement. We go down here, system.out.println I with a space. Well, I is 5, so we print 5 space, which generates this. Then we're at the end of our loop, and we go back up. Is I still less than 10? Well, yeah, it's 5. So we're going to run this loop again. I increments, becomes 6. If I is equal to 7, well, that is not true. So we go down here. We print I and a space. Current value is 6, so we print that 6 and the space. And we're at the end of it, so we go back up here. Is this test condition still true? Is I less than 10? Yes. So we're going to run a third time, increment our I, and now we get to see something more interesting happen. So if I is equal to 7, this time that's true. And it says continue. Okay. Well, continue means we're going to immediately jump from this back up to our test condition. We don't go down here and do the print line statement. So we go up here and we ask ourselves, is I less than 10? Yes, it is. So we're going to run this loop again. Increment I becomes 8. Is I equal to 7? This time it's not. And so we go down here and we print I and a space, and that prints the 8 in the space. You can see how it's going to happen again with 9. But we did not ever print a 7 in here. That's because this print statement was never reached whenever I was 7. Because whenever I was 7, we hit this continue, and it said, alright, we're done with this current iteration of the loop. Let's just immediately go to the next iteration of the loop. So we never got here when I was 7, and therefore 7 did not get printed. So those are the 3 new keywords, or I guess 4 new keywords. We've learned while, break, continue, and do. All of those keywords were learned in this lesson. Quite a bit going on. So sometimes these loops will require a whole lot more planning before you start coding. So I encourage you, have a piece of paper in front of you, trace through variables to plan things out, see why things aren't working correctly. Take it all step by step. Don't just throw numbers at it and hope that you get the right answer, because as things get more complicated, that approach isn't always going to work for you. So let's take a look at the labs, and I can maybe show you a couple problems before I let you loose on your own. Alright, so I've got BlueJ open, I'm ready to go. If you look at the practice problems here, you'll notice that they're not really like the last couple of labs that we've done, in that there's no real practical application to what's going on here. These are just simple exercises in can you put a loop together. We'll start with problem 1. Write the code using a while loop and a loop variable to produce the following output. 1, 2, 3, 4, 5, 6, 7, 8, 9. Note, it must be done with a while loop that will run 9 times. Okay, so when it says loop variable, that means I need to come up with some kind of variable that is going to increment as I go through my loop. So let's just say x. How about x? Let's set x equal to, well, where do we want to start? The first thing I want to print is the number 1. So I'm going to set x to be equal to 1. And then I'm going to, I know that I want to have a print statement. System.out.print. And I don't want to do a print line because I want all my output to be on a single line. And I want to print the value of x. But I don't want to just print the 1. I want this value of x to change and for it to print each time. So I want this to be inside of a loop. So I want to have a while loop of some kind. So I want to have a while loop of some kind, but I need a test condition. When do I want this to run? I want it to run as long as x is, once it gets to a certain point I want it to stop. So whenever it's 9 I want it to run, but when it's 10 I don't want it to run. So I want it to run for all the values less than 10. Does that sound reasonable? So while x is less than 10, we're going to do this. Now if you see that I run this, check out what we get. That's a whole lot of 1s, and it just keeps going. I have an infinite loop right now. Let me shut my program down. So that's because x never changes. So after I print x, then I'm going to want to change x. Let's make x go up by 1. And then every time this loops through, x goes up by 1. It prints the new value, goes up by 1. It keeps going through until finally, whenever x becomes 10, then it's no longer less than 10, and it should be done. So what do we get? We get the digits 1 through 9. Should have labeled it. That was problem 1. Problem 2 says do that exact same thing, except that we want spaces between them. So that sounds like a copy-paste job. Problem 2, after I print x, then I also want to print a space. Compile. Okay, so it's telling me that x was already defined. Up here I defined x. Notice that the scope of x is everything within the main method, so I can't declare x again, but I can just reset it to 1. So I can do that. I just can't have 2 variables called x. I can use the same one again. I just need to reset it back to 1. Compile and run. Alright, so we get what we wanted, but it's all on the same line as the previous one. So I should go in and put a system.out.print line just to put some spacing in there. There we go. So that looks pretty good. Alright, one other thing I want to show you real fast is the debugger. So this is pretty important that moving forward, as things get complicated, you're going to maybe have some logical problems in your code and you want to figure out what's going on. So I showed you how to trace it by hand with a piece of paper, keeping track of your variables, but BlueJ will also do that for you. So if I click right here on the line 7, I'm putting a stop sign right there. It's called a breakpoint, and that means that whenever I hit the run button, I run the main method, I get this window that pops up, debugger, and it stopped execution of my code in that spot, and it's not going to continue through until I tell it to. So I can use the step into button to go one line of code at a time, and I hit that, and you can see that we move down. This variable of x was just created, and you can see down here I now have a variable x and it has a value of 1. So is x less than 10? Yes, it is. So we hit step into, and you see that we go inside the while loop. It's going to print x, and it did print x. Now we have x plus plus, and we step again. So x just became 2. And you see that the execution just went back up here, so it's looping. And you can watch this clicking the step into to do one line of code at a time, and you can see what's happening up here as you go, and you can see down here the value of x at any time, and then you can see that as soon as it becomes 10, it jumps up here, tests this condition, and it was false, so we moved out and we're now moving on to other things in our code. So set those breakpoints, use the debugger, it's an amazing tool. Good luck on the rest of your labs.
Enjoying my class? Smash that like button. Don't forget to subscribe and follow me on TwitFace. But hey, that's just a tutorial. A computer science tutorial. Thanks for watching.